Hi guys, welcome to my PLM and Teamcenter channel. Today we'll learn how to elevate runtime properties in Siemens Teamcenter. I show you the easy steps to create them, perfect for PLM admins. Let's start. Please leave a like, it really helps, and subscribe clicking the button below. See you!
Hello everyone and welcome to my channel, dedicated to the world of PLM and Teamcenter. Today I'm diving into a super exciting topic, runtime properties in Teamcenter. We'll explore what they are, why they're so useful, and I'll guide you step by step on how to define, implement, and test them right in the client interface. If you're ready to jump into the world of Business Modeler IDE and ITK coding, stick with me. Don't forget to hit that like button and subscribe for more tutorials. Let's get started. So, what exactly are runtime properties? They're special properties of a business object in Teamcenter that aren't stored in the database. Instead, their values are calculated in real time whenever a user requests them. Imagine a field that shows, for example, the estimated launch date of a rocket by adding 30 days to a project's completion date. This value isn't fixed. It's generated on the spot based on other properties or custom logic. Why are they so powerful? They let you display dynamic information without overloading the database, making Teamcenter more flexible and tailored to your business needs. Think automatic calculations or dynamically updated statuses, all made possible with runtime properties. Want to see them in action? Let's move on. Today, I'll walk you through the entire workflow to create runtime properties, from setting up your development environment to deployment and testing. Here's the plan. We'll set up the development environment in Business Modeler IDE. We'll create 3 runtime properties for a custom business object. We'll generate the boilerplate code for these properties. We'll write custom logic in C++ using ITK. Finally, we'll deploy the package and test everything in the Teamcenter client interface. Are you ready? Let's open BMIDE and get to work. First, we need to set up our development environment for BMIDE. Locate the Business Modeler IDE icon on your desktop or in the Start menu, right-click it, and select Open File Location to access the program folder. Here you'll find the bmide.bat file. Open it with Notepad++ to edit it. We need to configure the environment variables for your Java installation. Add or modify these 3 variables before the path variable. JRE Home. Set this to your JRE installation path. Java Home. Set this to your JDK installation path. JDK Home. This should also point to your JDK path, same as Java Home. Make sure to save the changes to bmide.bat. Next, if you're on Windows and using Microsoft Visual Studio as your compiler, we need to call the vcvyars all.bat file to set up the compilation environment. In my case, the file is located in the Microsoft Visual Studio 2019 folder in Program Files. Add the line shown on the screen to the bmide.bat file. Save the batch again after adding this line. It's crucial to set these Java environment variables and call vcvarsal batch file if you're using Visual Studio to ensure BMIDE runs smoothly. Now let's launch the Business Modeler IDE, the key tool for customizing Teamcenter. If you've never used it before, don't worry. I'll guide you every step of the way. Once BMIDE is open, switch to the Advanced Perspective. Next, in the Navigator panel, select your project. Right-click on the project and choose Properties. We need to configure two key settings. Teamcenter installation path. Specify where Teamcenter is installed. For me, it's dplm-tc root. Select your main installation folder. Compiler Home. Set the path to your C++ compiler. I'm using Microsoft Visual Studio 2019, so my path is this one selected. Make sure to pick the right version for your system. Apply the changes and close the window. This setup is critical to ensure our ITK code compiles correctly. Pro tip: save these paths in a text file. It'll save you time on future projects. Next, navigate to the Extensions section in BMIDE under Code Generation Libraries. Right-click on Libraries and select New Library. Name it, for example, HDS4 Core. This library will hold all our custom code. Keep the Set as Active Library option checked and click Finish. See that green arrow next to the library? That means it's active. If you don't see it, right-click the library, go to Organize, and select Set as Active Library. This step is important because BMIDE will use this library to generate our code. Awesome, our environment is ready. Let's move on to creating the runtime properties. With our environment set up, let's define the runtime properties for our business object. In this example, we'll work with a custom object called HDS4 Rocket Revision, which represents a rocket revision. We'll create 3 runtime properties to enhance the data shown to users. Let's go through them one by one. In BMIDE, navigate to the Business Objects section, find HDS4 Rocket Revision, and double-click to open it. Go to the Properties tab. Here we'll define our dynamic properties. Our first property is HDS4 Estimated Launch Time, a date type. It will calculate the estimated launch date by adding 30 days to the persistent property completion date. Click Add, select Runtime Property, then Next. Enter the name HDS4 Estimated Launch Time, choose Date as the type, and click Next. Check Generate Getter to indicate we'll implement the calculation logic. Click Finish. Notice that in the Property Operations section, a getter operation has appeared for this property. We'll use it later to write the code. The second property is HDS4 Fuel Efficiency Status, a string type. It will display the fuel efficiency status based on the persistent property fuel consumption. The logic is high if consumption is below 100, medium if it's between 100 and 200, low if it's 200 or higher. Click Add, choose Runtime Property, enter the name HDS4 Fuel Efficiency Status, select String as the type, click Next, check Generate Getter, and hit Finish. Again, BMIDE has created the corresponding getter operation. The third property is HDS for Mission Readiness Score, an integer type. It's calculated using two persistent properties, test completion ratio, the test completion percentage, and system checks passed, the number of checks passed out of 50. The formula is test completion ratio x 0.6 plus system checks passed divided by 50 x 40. This gives 60% weight to tests and 40% to checks, creating a balanced score. In BMIDE, click Add Runtime Property, name it HDS4 Mission. Readiness score set type to integer, select Generate Getter, and hit Finish. Done! Next, we'll code it. Give a like if you're enjoying this. Now, our data model includes 3 runtime properties, each with its own getter ready for customization. Save the model by clicking File Save. Great job! We've defined the behavior of our properties in BMIDE. In the next step, we'll generate the boilerplate code and write our custom logic. Let's dive into that now. With our runtime properties defined, let's generate the code. In the Business Objects tab, select your project, right-click and choose Generate Code C++ Classes. This creates automatically generated files in the Output Generated HDS4 Core folder, which Teamcenter uses to integrate your code, but don't edit these files. Instead, we'll add our custom logic in the SRC Server HDS4 Core folder, specifically an HDS4 Rocket Revision impl file, where the magic happens. This file contains the skeleton for our 3 runtime properties. Teamcenter indicates where to write our implementation with the comment, Your Implementation. Let's start with the first one, Get HDS4 Estimated Launch Time Base. Since this is a runtime property, the code runs every time a user views the attribute in Teamcenter's interface. What do we want this property to return? It should calculate an estimated launch date based on the persistent attribute completion date. Here's a first draft of our code. Notice the try-catch block. Inside the try, we'll implement the logic for the runtime property. First, we uncomment the output parameters by removing the comment symbols, preparing them for use in our code. We declare a result status object to capture any exceptions during Teamcenter calls. It's super handy for error handling. We initialize HDS4 completion date to null date, and the output parameter is null to true. Let's write the code. We start with an entry log for our function, get HDS4 estimated launch time base. Entering. We'll add a similar log at the end for exiting. Inside the try block, we declare rocket rev tag as the result of calling get HDS4 rocket revision, get tag, which gives us the tag of our rocket revision. We use this tag to fetch the HDS4 completion date attribute. We compare HDS4 completion date to null date. If it's different from null date, we calculate the estimated launch time by adding 30 days to the completion date. To do this, we use a utility function called SumDateWithSeconds, which takes the completion date and the seconds equivalent of 30 days. Finally, we set the output is null to false. Let's take a quick look at SumDate with seconds. This function takes a date and a number of seconds and returns a new date with those seconds added. At the end of the code, we log the exit. Get HDS for estimated launch time base exiting. We return the iFail variable, which will be ITKIOK if there are no errors. If an exception occurs during an ITK call to Teamcenter, it's caught by result status, which throws the exception. The catch block saves the error code to iFail, which we return, and we also log any error message. That's our first getter implementation for HDS for estimated launch time. Now, let's move to the getter for HDS for fuel efficiency status. We uncomment the output parameters. This follows the same structure. We use result status for exception handling and initialize HDS for fuel consumption to 0.0 and is null to true. The initial code is similar to the previous method. We retrieve the rocket rev tag using get HDS for rocket revision, get tag, and read the persistent attribute HDS for fuel consumption. We check if fuel consumption is valid, greater than 0.0. Our logic determines the status. If HDS for fuel consumption is less than 100, the efficiency is high. If it's between 100 and 200, it's medium. Otherwise, it's low. Finally, we implement the last runtime property, HDS for mission readiness score. Again, we start with the standard skeleton. This property relies on two attributes, test completion ratio and system checks passed. We retrieve the rocket rev tag, read test completion ratio and system checks passed, and if both values are valid, we calculate the score using this formula. Test completion ratio x 0.6 plus system checks passed divided by 50 x 40. This gives 60% weight to tests and 40% to checks, creating a balanced score. We set isNull to false and finish by returning ITKOK. Let's save the file and compile it by going to Project, Build, Project. At first, you'll notice some errors because we forgot to declare the necessary header files. Let's add these headers, iFail, TC result status, AOM, and AOMProp. Save the code again and rerun Project Build Project. This time, the build completes with 0 errors. Nice. Teamcenter generates the library libhds4core.diell in the output/Windows 64/lib folder. Now select your project and go to BMIDE, Generate Software Package. Copy the path where the package will be generated and click Finish. Next, open the Environment Manager, select Perform Maintenance on an existing configuration, click Next, and choose Update Database, Full Model. Enter the password, select the generated package in the Full Update folder, and proceed with the deployment. Once it's done, the runtime properties are successfully installed. Now let's verify that the libhds4core.ell library has been placed in the tc root/bin folder. It's there. Perfect. All right, let's see our runtime properties come to life. Open Active Workspace, log in with a test user, and create a new Rocket object named Rocket with runtime props1. Head to the Mission Dashboard tab. Here, our runtime properties are displayed in 3 sections: Launch Schedule, Fuel Performance, and Readiness Overview. Click Edit and set these values. Completion date to today, June 5th, 2025. Fuel consumption to 150.67, test completion ratio to 20.50, and system checks passed to 20. Hit save and check this out. Estimated launch time shows July 5th, 2025, 30 days later. Fuel efficiency status is medium, since 150.67 is between 100 and 200. And mission readiness score is 28, perfectly matching our formula. How cool is that? Drop a like if you're impressed, and share your Teamcenter experiments in the comments. Let's recap what we've done. We set up the development environment, modifying the bmide.bat file, and configured the compiler and TC root in bmide settings, created the libHDS4 core library for our customizations, defined the runtime properties in the business modeler, generated C++ classes to implement their getters, and finally generated and deployed the package in Teamcenter. I hope you found this tutorial helpful. If you have any questions, drop them in the comments below. I'd love to hear your Teamcenter challenges. Don't forget to like, share, and subscribe for more tips. See you in the next video with another exciting topic.